questions, scan the QR code, and we'll do our best to answer them all. You can also talk to the speakers after the presentation. And now I'm inviting Evgeny Blinov from VK. Let's give him a round of applause.
Всем привет.
Hello, everybody. I'm not offering to cancel PhD days too. We will be talking about Python today. And a couple of words about myself. My name is Evgeny Blinov. I work in VK as a team lead, and I write a lot of Python code, different things. And of course, there are some challenges that I face that I'm going to talk to you about today. A couple of words about myself. I have my Telegram. Send me messages at night, during the day. Send me messages on GitHub, on LinkedIn. And now I have my personal site. Check what is there if you want. And the question is, as we are programmers here mostly, and the topic is mostly about programming, let's start with my topic of today, which is when we write some code, at some point in time, we might need to cancel the execution of the code. Let's try to think it over. The main reason could be is that we don't need the result anymore. Usually, those are situations of asynchronous calculation when the decision about doing something is spread in time with the end of the task. Like if we decided at 12 o'clock that we'll be doing something for 5 minutes, during those 5 minutes, a lot can happen. Hence, we no longer need the result. Like the user decided that he cannot find something or cannot get the result of the calculation and leaves. There's no need to continue. Modern users do not have very focused attention, so the result might not be needed if you're on TikTok. Or you can learn something that makes the further work senseless. Like you decided to learn the cost of the stock, and at the same time, you run another worker that would try to find out if their company exists for this stock. And you find out that there's no company like that. So there's no need to learn the price of the stock. Or you create software for the robot to fill some boxes with goods, but there are no boxes. The robot can keep kind of trying to put goods in the box that is overfilled, but you need to stop it, of course. Or you send your kid to buy some bread, but after he left the house, you found a loaf of bread in the storage. So those situations, when you decided and when you got the result, are spread in time. For example, you learned that you have another child that went to get some bread. And of course, you wouldn't need the kid with the bread any longer. The second alternative is when the task costs too much for us. Like imagine we have a time limit and we are out of limit. For example, the kid has 5 minutes to get the bread. We spend 30 minutes and we call him and we say, don't buy any bread. Just come home. Or you went to buy an iPhone, something happened, iPhones are twice more expensive, and you are no longer interested in buying a new iPhone. So what is the cancellation token? My main topic here is cancellation tokens, not about canceling the page days or something else. Cancellation token is a pattern.
Это паттерн, про который я узнал от коллеги,
который написал
на C#. То есть это не распространенный в Python паттерн.
Shown to me by a C# colleague, and it's not widespread in Python. The reason why I go to Python events, I tell the other Python developers this knowledge about cancellation tokens. This pattern is a form of dependency injection. It means that you have some code that previously you could write as if the time passed after the start of the job is more than 5 minutes, exit. We no longer put that condition in the code, but instead we put some object in the code, and that is the object that we ask whether we should stop execution of the code. Nothing else would tell the code to stop. The code will have an object, and what is the best part about it? It's because your code can decide when it can stop working. Your code can ask the object, or for some reason, it can do some operation that does not have an option to stop, so your code will stop execution correctly. It's not a forceful termination of the process or the job. You don't plug it off and see the data being inconsistent. So tokens are a very convenient thing, because if they are the only things that have the termination condition, and you can, for example, sum them together, sum two tokens, your code will not know anything about it. So only the token operations would define when and how your code execution will finish. One of the ways to use it is throw in the token through the call chain. So imagine you have a function that is nested in another function, and you have a stack of functions. For all the functions, you can use the token, the core token, for example, that can cancel, create cancellation events by the user, and you throw it through the code. And for example, if you have a limitation of 5 minutes for the code execution, you can have another limitation saying, hey, please check whether this token or this flag is set. And then, if it's present, then stop execution. So besides the fact that the cancellation token is a pattern, it's an object in your code that you ask whether the job is done. So this object is by default not cancelled, not stopped. And if you just create it and ask if the operation was cancelled, the answer is no. So it will only say yes if someone changed it into the cancellation state. Cancellation token can encapsulate the different reasons that the execution can be stopped. For example, user termination, or timeout termination, or some other options. Regardless of the many options, the many reasons, you process it
Логичный вопрос.
in
Питонисты без
one
этой
consistent
техники
way.
жили миллионы лет, размножались,
So
бегали по
Python
лужайкам,
developers were
гоняли
living with
бабочек,
it
и ничего
without
не
it for many
прибавилось.
years,
Зачем это все нужно?
They were multiplying and enjoying life.
Очевидно,
Why would we need it?
ответ заключается в том, что ваш код таким образом упрощается.
The reason is it makes your code simpler.
Он будет завершен, когда
If your code no longer knows the reasons for cancellation, if there's no extra ifs, the code is easier to read. It becomes more compact. If you removed all those ifs, then the size of the code is smaller. The main consequence of that, it has less bugs. Less code, less bugs. The amount of bugs is usually proportional to the amount of lines in the code. So your code base is unified. So if you talk to a colleague about some module in your code and your colleague says that your common code is terminated after 5 minutes, 5 minutes after the start, you need to look for this cancellation token, if you have agreed, of course, with your colleague that you use them for termination. So the tokens are an agreement that simplifies your work as a team. You can also use the token as the synchronization primitive, throwing them between the threads, some thread pools from main thread, and other operations. It becomes much easier to support the code because the reason for termination and the code logic change independently most of the time. Meaning that your main business logic that you throw the token on does not change. You just change the token. The logic stays the same. If part of the code is changed less frequently, then it's easier to support and cheaper to support the code. And the obvious consequence of that, if the code is smaller and easier to support, then it's easier to test. If you've created some code that accepts that termination token and terminates with the token, then you no longer need to test the code for multiple cancellation reasons. If your code had 50 conditions for termination, and all those were if clauses, and you just migrated all of them into the token, into the cancellation token, then now you only need to test that the token that you can call via a method, the code terminates by the token, and that's the only thing you need to test. So I told you about the tokens. Probably it was quite abstract. Something responsible for cancellation. And this can be hard to comprehend, so here is an example.
В данном случае на примере вы видите класс, у которого есть один
атрибут that has one attribute cancelled.
False.
By default, it's false.
Метод cancel, он станет.
But if you call the cancel method, then it's true.
Эта ситуация как раз демонстрирует самый простой способ работы.
This situation illustrates the simplest scenario of working with a cancellation token. By default, it's not cancelled, and if you cancel it, it's cancelled. This implementation is enough for your project to have the pattern, the cancellation token pattern implemented. And if you cannot use external libraries, that's the right way to go. Luckily, Python programmers have huge respect for libraries, and they do it. They do use them. So when I needed the library with cancellation tokens, The first library I found was cancel token. It looked very much like this. The token that was there could be cancelled or not, and you could call the cancel method. That was pretty much it. There's a more complicated library called async cancel token, and it's intended for async code. It's quite developed. It allows you to create tokens that cancel for timeout. It's a huge advantage. But in everything else, it's not mature enough and does not have a lot of cancellation capabilities that I would want. And the last library I'm going to talk to you about is cantok. Actually, I have a couple of slides about those libraries. Cantok. Third library, here's the QR code. And in my opinion, this is the most well-developed and functioning library with cancellation tokens. There's different types of tokens that you work in the same way, that you process in the same way. You can call the cancel method, the token that cancels itself by a timeout. If you create an object of this token, it remembers the time when it was created and immediately sets the deadline for itself. So if it was told that it's a 1 second timeout token, then that deadline is remembered, and after 1 second it starts to reply that it's cancelled. If after the deadline you ask it, you get your cancel. That's there's also arbitrary condition cancellation that enables you to implement some cancellation abstracts and merge them together. My cantok library applies for all types of code. It works for async, it works for multi-threaded code, but the only thing it's not intended for is multi-process calculations, multi-process calculations when you cannot actually throw it between processes. There's a lot of syntactic sugar. You can summarize the tokens, you can nest the tokens. All token classes and all objects within cantok are thread safe. You can use them even as a synchronization events. This will work. They are all implementations of abstract token with a similar interface, with one interface. You can call the same methods regardless of which token classes you work with. Also, all the tokens cannot be undone. So if it was cancelled, then it cannot become non-cancelled. All the tokens have their own exceptions. Further details will come later, but you can catch an exception from a token. You can ask the token to throw an exception if it's cancelled. You would know the reason why this exception appeared. So if this token was cancelled by timeout, then it will be called the timeout exception. And second, you'll see the message that the timeout was 3 minutes. You will know more about it. All the tokens can be converted to Boolean, meaning you can create cycles like while token and conditions like if token. It makes your code very compact and easy to understand. I told you about simple token and mentioned it in my speech.
Показать, как эта штука выглядит. Simple token — это простейший токен из библиотеки cantok.
So now it's time to show you how it looks.
Из cantok
It's the simplest token from cantok. It's imported and instanced without any arguments, without any parameters. So you convert it to bool. By default, it's true. After converting it to boolean, and it's false. So for the cycles that will run until the token is false, then it's ideal. One of the features, one of the things how you can use this token in your code, usually you would not consciously use and pass those tokens to the function. More often, I think you can use it as a default function argument. Simple token that can be only cancelled via the cancel method is probably not good for all the types of usages. But you can create a function that would take that simple token but would also accept any other token. It's convenient if you create libraries. Next token type is timeout token. Unlike a simple token that doesn't have anything in its constructor, you would have the number of seconds. And after those amount of seconds have passed, then the answer will be yes, cancelled, regardless of whether it was cancelled by the user. Not much more to explain here. Condition token accepts the first parameter, something callable, without arguments. So this callable should answer whether this operation that's going on now is cancelled. And unless this callable is answering no, replying false, the token will keep saying that it's not cancelled. This type of token is very convenient for using with those putting some local, for example, variables into those lambdas just to create a connection. And the logic that you can put in there can be quite complex. Here are the main types of tokens, patterns, libraries that implement that pattern. I showed you my library, the tokens within it. And let's dive deeper into what is the token from a cantok library. Suddenly, it's a tree. Why is it so? Because the token can include other tokens. You can nest tokens within each other. I said on the first slide that you can run operations between tokens. So besides your main code, you can do operations with tokens outside of your main code, like nesting.
Есть пример кода, как это можно делать.
Here's an example of the code, how it can be done.
Создаем два токена и создаем третий токен.
Simple token code. You create two tokens and you create another token that includes the other two. So besides the arguments that are needed for the tokens to work, can accept optional arguments like other tokens. So this simple token would take the other two simple tokens. So the cancellation of any of those two will give you the cancellation of the parent one. So if you ask the third token, it will check if it was cancelled by the user, and it will check whether it is whether any of the nested tokens are cancelled. So they might also include other tokens, so they will check their own cancellation conditions, and then they will check all the other tokens. So by asking about token status, you do DFS, graph
Да,
processing,
токен — это еще и фрактал. На самом деле это
and it's also a
вы
fractal.
просто должны себе визуально
Just for the
представлять, что
beauty of
такое
it,
токены.
you need
Вот
to
один
imagine
токен,
tokens
несмотря на
as
то, что он имеет простой интерфейс,
one token,
внутри
despite
может
having
иметь довольно
simple
сложную
interface,
структуру вложенных в него
can
токенов,
have a
которые вложены еще
complex
токены, еще
structure of
токены, еще
other
токены, еще
tokens
токены.
inside it.
Я вставил это просто, чтобы вы понимали,
And
что операция сложная и потенциально тяжелая.
I gave it to you because I need you to
Токены можно
understand this is
суммировать.
potentially
Это значит,
a long
что
operation. You can
условия
also summarize the
токенов,
tokens,
которые вы суммируете, будут объединены через
and
или.
they will be
То есть,
merged
если любой из
through
токенов,
or,
который вы суммируете,
meaning
отменен,
that if any of the
результирующий
tokens
токен, который
that you are
получился,
trying
тоже будет
to sum
отменен. На самом деле,
is cancelled,
сложение
then
токенов
the
это
result will be
подвид
cancelled.
сложение
So
токенов. То есть я вам на предыдущем слайде показывал, что токены можно вкладывать друг в друга. Так вот,
summing
сложение
of
— это
tokens
просто
is
синтактический сахар над вложением токенов. Это
in
очень
part
удобно для вот того способа использования, про который я рассказывал
looks
вначале, что
like
можно прокидывать токены через
merging of
стек вызовов,
tokens.
постепенно
If you remember,
ужесточая
I told
увеличение
you
вот
that
эти
you can
ужесточения.
throw the
Очень
tokens
красиво
through
и
the
компактно
call
получается
stack.
делать через плюсики.
And the most beautiful and compact way of doing
Да,
it
все про это
will
рассказал.
be through the plus.
Следующий момент. Токены, как я уже говорил,
One more
удобно
thing,
приводить к булу.
tokens, as I said, are easily
Это
converted to
удобно
Boolean.
для циклов, и это удобно для условий.
It's
Собственно, вот вам пример кода, как
convenient
это
for the
делается.
cycles,
Я думаю,
and
здесь
here's an
сложно
example
его
of the code
комментировать. Пойдем дальше.
that does this. Not much to
Ожидание
comment.
отмены.
Let's go
У всех
further.
токенов есть
Cancellation
метод wait.
expectation. Every
И
token
если вы
has a
дернете
wait
этот
method.
метод, вы зависнете до
And
момента,
if you call
пока
that
токен не
method,
будет отменен.
you will
Это довольно, на самом деле, как мне представляется,
hold
редкий use case в нашем коде,
till the moment
но иногда может быть
when the
полезно.
token is cancelled.
То есть вы
It's a rare
можете
occasion,
забросить
but
что-нибудь
sometimes it
какому-нибудь
might be
воркеру
useful,
и
like you send
ожидать, пока
something
этот
to a
воркер
worker
отменит ваш
and expect the worker to
токен.
cancel
То есть
your
основной код
token.
ждет,
So then the
когда
main
этот побочный код выполнится.
would wait for
Реализация
some other
конкретного
code to
библиотеки
execute.
cantok, она необычная, про это немножко будет
Cantok
дальше.
implementation
Но
is a
если
little bit
вкратце, то
special,
async и sync
but
версии ожидания
both
отмены
async
выглядят
and
одинаково.
sync
То есть и
version
там вы дергаете метод wait,
cancellation
но
expectation
только в том случае,
would
если вы
look
ставите
the same.
предварительно слово
You
await
call
или
the wait
что-то
method,
аналогичное по смыслу,
or
вы получите,
you add the
у
await
вас
word,
сработает асинхронная версия кода.
and you will
В
have
противном
the
случае это будет
async version of
асинхронно.
the
Про это
code.
будет дальше.
Otherwise, you will have a synchronous version of the
Такой
code.
момент есть,
Couple of words about
который
it
пока
later.
что не исправлен. Это,
There's
можно сказать, что это
also
главный недостаток библиотеки cantok.
negative side
Состоит
of
в том, что
cantok
если
library,
вы
which is if you
пишете асинхронное приложение и забыли
create
добавить await,
an async
обычно,
application and
когда вы
forgot to add
пишете,
await,
например, карутину в вашем коде, создаете ее
then
и забыли ее
if
завысить,
you are creating
вам
a routine in your code and forgot to await it,
в моем случае ругаться не
the
будет.
interpreter will tell you
запустит,
about it. But in my case, the interpreter will
Вот, с
just
этим я знаю, как бороться, но пока не
launch the
реализовал.
synchronous version
Я
and
думаю,
block
что
the
для
event
этого
loop
нужно
for you.
написать какой-нибудь плагин для какого-нибудь популярного
I
линтера. Любой из
am
вас
quite
может взяться
sure
и
that
сделать это, если есть желание.
it's fixable through a plugin to any linter.
Ну так вот,
So if you want to help open source,
просто
then
принимать
do it.
который
This plugin
ему
will
скажет, это
accept a
приложение или
boolean
асинхронное.
and
Если написано,
tell
что
it
это
whether the
асинхронное
application
приложение,
is
и он
synchronous
видит
or
где-либо
asynchronous.
в коде вызов
And
метода wait у токена
if you see
без
a wait
wait,
method in a
он должен
token
ругаться.
without a
Он
wait,
должен не пускать такой код.
then you should throw an
Итак,
exception
я уже сказал, бывает два
and not
способа
allow this code to
отмены,
execute.
и там используется метод
As
wait.
I said, there are
Вот в
two
примере,
cancellation
я
methods. Both
запускаю это через
options
gather, но
include
я также
wait
могу
method,
через await сделать. Это примерно то же
but
самое.
I could also use it
И
through
мы
a
видим,
wait.
что
And
в
we
данном
see
случае
that in this
оно
case,
вполне нормально awaitится. И когда оно awaitится,
the await
параллельно могут
works
выполняться другие операции.
and
Async
you can actually run
вполне
other
корректно
operations.
работает.
So
Однако
in
мы можем
async,
не пользоваться
this works fine.
async версией, мы можем
But
тот же
we
самый
can
метод
also
wait
avoid using
вызвать
the
вот
async
так.
version and
И это
call
тоже
the
будет
wait
работать.
method
Без
in
всяких
this way
лупов. Этот код будет работать.
without any event loops. This
Это
code will work,
немножко магично.
and
Когда
this looks
питонисты
like
видят это в
magic
первый раз, им нужно объяснять
when
то, как это
Pythonists
устроено
see
под
it,
капотом.
they would be surprised, and you need to explain how this works under the hood. And usually I speak for half an hour. Now I have 40 minutes, so I will explain how it works. Python interpreter has a lint counter, so that each variable would have some attribute, some int, and when you create another variable that looks at this object, this int is incremented. If you destroy this variable, it was a local variable, this counter decrements. When it's 0, then the interpreter would delete the variable. So this mechanism allows us developers for an interesting possibility. We can track the lifespan of the object, and using the events that happened during this lifespan, understand how this object was used. So if you have a wait method, and this method returns some calculation, and if it was deleted by the interpreter, then the method will remember, and when I am deleted, I will not be doing anything. So when we await this object, the asynchronous waiting is happening. But if we don't do anything during the life cycle of the object, and the interpreter is deleting it, then the callback is initiated, and the object remembers whether it was awaited at least once, and remembers that it was not awaited, and it hangs. It does not delete unless the token is deleted. So that's the way this variability is implemented.
Exceptions. I've already said that every type of tokens have their own exceptions. For instance, when you are calling the check method from a token with a timeout, and this token has been cancelled by timeout, you'll see the exception timeout error. If you do the same for a usual simple token, you just see a cancellation error. So this difference in exceptions allows you to set up your code in a finer way to work with different reasons of cancellation. I don't recommend abusing this. I recommend you write code that is more universal. So largely speaking, code shouldn't know the reason why it's been cancelled. Actually, it's just a trick if you need that for some reason, but it's always better that you don't need that. Check works based on the DFS algorithm. Another important point, any token cancelled by the method cancelled is treated like cancelled manually. So if you call check, then you'll always get cancellation error, regardless of which type of token has been used. If the cancellation reason was specific, for instance, if it's a condition token and you haven't cancelled it manually, then it cancelled by some condition that you've said. So in this case, this will be a specific exceptions. Inherited from cancellation error. Every exception has a message or generates a message explaining the reason, an accurate reason why the cancellation happened. It usually consists of the token symbol showing the token has been cancelled by someone or something. If a condition token has been cancelled that learns about a certain condition, then it will be mentioned that the condition of this cancellation has been met. Every exception that's raised by the check method contains the token attribute. And this attribute contains the token that has been cancelled. You may ask why. So we have a specific token, it never went away, and for some reason, exception again mentions this token. The answer is in the DFS algorithm. Basically, in actual life, not the token that you requested can be cancelled, but some of the nested tokens nested inside this, belonging to the tree or the fractal of tokens. And so in the token attribute, you'll see the first token that has been found during the DFS process that has been cancelled. Not necessarily the one that you requested specifically. It can be any one of them. Let's now talk about the target audience. The target audience are basically all who are writing code in Python. It can be useful for everyone, but the core audience that I believe this presentation is important for includes those people who write libraries and frameworks themselves. A lot of libraries spend a lot of time carrying out some operations. If you're writing this operation, it's good if your function methods should accept the cancellation token as an optional element. So you don't do like most people as a timeout, as some number. No, you accept a token. If the user believes that they want to be cancelled by timeout, they create a timeout token and pass it on to you. If the user believes that they want to be cancelled by some condition, they'll create a condition token and pass it over to you. So your library stops knowing why an operation inside it should be cancelled. It's defined by the user, your library. Another thing, those who are writing services. Services are a thing that SLAs apply to sometimes. So if, for instance, there are certain rules that you've agreed about with stakeholders, and these stakeholders may tell you that the answers from your service shouldn't arrive later than, let's say, 50 days after the call. So please, they say, 50 days is too much for us. So you can create a token for 50 days, pass it to some functions and methods within your code, and in such a way guarantee something close to this time limit. An important point that you need to take account of if you're writing in the SLA-based services. You can have an SLA expressed in some response time. The token doesn't guarantee that this SLA will be observed. Firstly, the code where you pass this token will have to check your token every time. It will have to check if the token has been cancelled or not. But if the code does not check it, then whether you pass the token there or not, nothing changes. So the presence of token as such does not guarantee the execution time. You should be checking the token status all the time. And the second point, as I said, tokens do not cancel code in a mandatory way. They offer the code a way that they have to be cancelled if it wants to know it. But starting from the moment when the code learns that it has to be cancelled, some time may elapse until it actually happens. So when you set SLA as a token, you need to bear in mind that this gap exists. Your token has known that it has to be cancelled. It needs some other time to get completed. So you need to allow some extra time. You don't set, SLA with token timeout. Those are writing heavy software. If from the time of launch of some operation to the moment of its completion, a lot of time needs to, you'll need cancellation tokens. This applies to all who are writing some ML. In the case of ML, the situation is quite typical. We always get some pipelines, some entity through which some data passes, and this data goes through a stepwise processing. So it's important that at least in every step of this pipeline we should check And ideally, that we do it even
Здесь вы видите
within the
ссылочки.
steps of the
Все
pipeline.
делайте все, что
Here you
естественно
see the
рекомендую. Да,
references,
теперь
the
можно пробовать.
links. Please do whatever I recommended. And now I'm prepared to take your applause. And now you can clap your hands. And I will start asking questions. Reminding you, once again, that questions are to be asked using the chat bot. I already have a short list of questions for you. And by the way, you'll need to select the best question to win a prize for. Nikita Pastukhov, what are the best practices for sharing one token instance between specific operators? For instance, when the user wants to cancel an operation via another manual operation. You shouldn't do that. This is the best practice. Your other manual thing. So look how web server works. The web server can launch query processes in different processes, and you can also have several web servers that run on different instances of your application. And if you create a token in one of the worker processes and cancel it from another worker process, this cancellation may not reach it. That limits the scalability of the app. Don't do that. Don't use tokens globally in the application. Tokens are intended for a specific operation. When you've already called some processor in your code, you can only create this token for this operation and then to pass it on to other functions and methods. Okay, Gennady is asking. Thank you for your presentation. Do you have any plans to add something similar to Afterfunk in Golang? I don't. It's a mechanism to register functions that will be called once the token is cancelled. No, I don't have such ideas.
Вопросы, на которые у меня нет идей, есть один ответ.
I always have the same answer to such questions. So just submit an issue and explain specifically why you need to say when you need this Afterfunk. It may also be possible that such a thing is already implemented because the library is quite big. But if it isn't yet, and if I like the idea, I may implement it. Andrew is asking, is there any room to improve sorting in JDK? No. Improving the sorting in JDK. I can't comment. I have no information. Maybe there is. I'm sure there is, because I believe that everything that exists on this planet is unoptimal. Everything can be improved, has room for improvement. Okay, Artyom Okolov, how to aggregate linkers in sync on async wait. How do they respond? Well, they don't respond. I want to fix it. I need them to respond. Okay, Yegor, an idea. Can the token addition can be used the operator? Perhaps I'll show it to you. This operator.
Палочка.
It's a bar, like the sign or. If token A completes or token B completes. Actually, I already had this proposal. My mind somehow thinks that plus is looks more idiomatic for Python people. But it hasn't been for the first time that maybe other symbols will work better than a plus sign. Another question from Andrew is saying maybe you should a bar or and.
Вот каждый раз, когда я в презентации использую слово «или», оно у меня в этой презентации прозвучало и, видимо, триггернуло всех людей, которые предлагают палочку для «или». У нас есть палочка.
This triggers people who propose a bar. Well, I suggest a pipe. I suggest that a pipe may be easier to understand for those people who are familiar with logical operations. Maybe it might make sense to make it synonymous to plus, so that people could use both a plus sign and a pipe. That has to be thought about, because the design of these things gets into what people feel natural. I don't want people to think too much in the process of code writing, because tokens should be present in the code everywhere, and it should be quite natural, something obvious. So one needs to think, oh, maybe I'll add. Okay, Sergey Shlanin said, you said that a cancel token can't come back again. Why does it happen? Does it depend on the check method being called in this period of time? Yes, it'll depend on this. Within the condition token, there's a callable that's been passed to it. And the fact of a token being cancelled is going to be explicit only at the moment when we call this callable. So we need to call this callable to see if the token has been cancelled or not. If in the period between the learning of the token status, but your function has not learned it, the token, unfortunately, doesn't have any magic ways to learn it. Only calling the callable. Another important point is that the result of calling this callable is cached. So if you've called this token once and it reported, so it's called its callable, and the callable told you that the callable has been cancelled, and after that it has started to return the answer that the token has not been cancelled, it will not be asked again. So we don't call callable after we get an answer the token has been cancelled. Okay, Mark. Why tokens are passed to the exception to which the task is cancelled? It's a great question. This is done for people who haven't listened to this presentation and who don't know about the pattern. There are people who want to learn the reason for cancellation and to do something based on that. I said it in my presentation, and let me repeat, I think it's bad practice. But there are very rare situations, and there are people who may want very much to do it. I know that people will be asking about this functionality. I know for sure that if you ask 1,000 people, then sooner or later some of them will ask for the opportunity to learn about the reason why the token has been cancelled. It was easy to do, and that's why I added it. Had it cost a lot, had it required any additional swipes across the token trees, I wouldn't have done that. But because we've already done this run on the token tree, we already know the token and why it was cancelled. Why not to attach it to the exception? Okay, don't you think that it's better not to use the cancel or the cancellation token? It looks like this. One could say this use case of synchronization could be solved by other tools, barriers, conditions, and others. Doesn't this pattern make the implementation too sophisticated, too complex? That's an interesting question. I'm always all for using as simple synchronization primitives as possible. The use of tokens can be justified by using some complex cumulative conditions. For instance, you have 5 conditions, and you want any of them to terminate your code. No. Conditions is a bad analogy. Okay. Put it this way. We have 5 workers. And imagine you have 5 kids. And you send 5 kids to different stores for different breads. You need one bread. You only need one loaf of bread. And you're sending all 5 kids to the 5 different stores and are waiting while at least one kid returns with a loaf of bread. After that, you take your mobile phone, call the other children and say, please don't come back home with bread. So if you've already bought it, go right to the orphanage. I'm joking, of course. But this is basically a way how we use the cancellation token in waiting. If we need just something once, but there are a lot of workers that can be given us a lot of instances. So I'll ask you 2 more questions, and I'm sorry for those questions I haven't asked. Lyric Dev, I like the start of this question. My name's Evgeny Blinov. Brother, I found you. So, is my understanding correct that I need to check a cancel token after every function? Well, look, the general answer is, if you want the time of this idling after you've already decided to cancel the operation to be as short as possible, you need to verify the token status in your code as frequently as possible. Wherever you can insert this token verification, do that. You can, if you use cycles, I recommend using token as an additional cycle condition. For instance, you have some while cycle with some conditions, you add this condition and token. And both the condition match and the token cancellation will stop the processing. Okay, and the last question. In fact, 2 people asked almost at the same time, the same question at almost the same time. Nikonov is asking, can you give examples of using the cancellation token in real-life projects? And Sonia Borovkova specifically, can you get a specific case of using code from real practice? And by the way, Sonia Borovkova believes that your presentation has been just great. So basically, my situation was that I first felt a need in the cancellation tokens and then wrote the library. So it's used quite often in my projects, not only public. And by the way, I have GitHub. And in this GitHub, I have several other libraries that depend on the tokens. Also, I have some projects at work, but unfortunately, I can't show to you. For instance, we have token testing. For instance, we're testing some service using Selenium, and in this Selenium, we have certain things that we expect. For instance, that some object should appear on the screen. We're waiting for that. And in our case, it's realized using the cancellation token. Why didn't we do this using Selenium tools? Because apart from some conditions, we want to get restricted by some timeouts, and tokens are quite comfortable to be used in such situations. Okay, great. Thank you very much. And now the best question, in your opinion, the best question. Well, I will give the reward to the question about the plus and the pipe. I remember there were more than one about the pipe. Yes, dear friends, last time we couldn't select the best question, and then they informed me that I am entitled to award 2 prizes. So, Yegor, are you here? Yegor, you're welcome. And Andrew E. Andrew C.
Who is Andrew C?
Who is Andrew C? Are you Andrew C? And you're Yegor, and you're sitting next to one another. How funny. So the prize goes to Andrew C. and Yegor. Thank you, and a round of applause to Evgeny for the presentation.